refer to this problem on circles. There is the circle x squared plus y squared equal to 100. Obviously, you know the center of the circle is 0, 0 and radius 10, right? And there is a point P 8, 6 on the circle. As you can see, 8 square plus 6 square is 100, right? Now, I'm selecting 2 points A and B on the circle that are 4 units away from P. I'm selecting 2 points A and B on the circle that are 4 units away from P. I want to be able to find the equation of AB. I want to be able to find the equation of AB. Now what we can do here is, although you know there could be many ways of handling this, but this one I prefer for this problem. What we could do is, we could draw a circle with center at P. We could draw a circle whose center is P. We could draw a circle with center as P. This is the circle with center as P. This circle with center 8, 6 and radius 4 units. This is a circle centered at P and passing through A and B. That means radius 4 units. Let me find the equation of this circle. What's the equation of the circle with center 8, 6 and radius 4? I'm sorry, I've not drawn too good a circle because I wasn't left with enough room above. But this is the arc, which makes sense, right? Whose center is P and whose radius is PA or PB, which is. So the equation of the circle is going to be x minus 8 whole squared plus y minus 6 whole squared equal to 16. That's the equation of the circle, 4 squared, right? Which is like x squared plus y squared minus 16x minus 12y, 64 plus 36, 100 minus 86, 64 plus 36, 100 minus 86, which is 100 minus 16, which is 84, is 0. I hope you realize 8 square plus 6 square, 100 minus 16, which is 84 equal to 0 is the equation of the circle, right? Let me call it S equal to this. And this circle, the blue circle, is like S prime, which is x square plus y squared minus 100 equal to 0. I know this circle and I know this circle, and AB is realized the common chord of the two circles. Equation of the common chord of two circles, S equal to 0 and S prime equal to 0. AB, the common chord, is going to be S minus S prime equal to 0. S minus S prime equal to 0 is like 16x minus 16x minus 12y, and then 84 plus 184 equal to 0. You can further write it as 4x plus 3y minus 46 equal to 0 would be the equation of the common chord. 4x plus 3y, 6 minus 46 equal to 0. That will be the equation of AB. Yes or no? Smart problem. I thought not difficult, but made sense. Thank you so much. Bye. So, refer to this situation. These are two circles. Let me call this circle S1 and this is circle S2. S2. And they are concentric circles. They are concentric circles. They have a common center O. One is of radius R1, the other one is of radius R2. Now what's given is that this inner circle divides this region into two equal areas. This inner circle divides this bigger circle into two equal areas. One is this area and the other one is this area. Other one is this area. Right. And that means two equal areas. The inner circle divides the outer circle into two equal areas. That means the shaded region is the same as the blank region. We want to find the, if I now select a point P on the bigger circle and draw pairs of tangents PA and PB, and if I draw pairs of tangents PA and PB on the inner circle, I want to find the angle between the two tangents. R1 is the radius of the inner circle, R2 the radius of the outer circle. Very clearly, the inner circle is of area pi r1 squared, this region, and that must be equal to the region of the annulus. The region of the annulus has area pi into r2 squared minus r1 squared. So if I transpose, I get r2 squared is 2r1 squared, or r2 is root 2 times r1. That means the radius of the outer circle is root 2 times the radius of the inner circle. That means if the radius of the outer circle is root 2 times the radius of the inner circle, this circle must be the director circle of the inner circle. And if it's the director circle of the inner circle, if I choose any point P on the circle, then the tangents must be perpendicular to each other. So angle between PA and PB must be 90 degrees. Yes or no? Thank you so much. Bye. Look at this problem. There is a circle given to us, x square plus y square equal to 3 plus 2 root 2 whole square. This obviously is a circle with center 0, 0, and the radius of the circle is 3 plus 2 root 2. This is this circle, right? And there is a point P selected on the director circle of the circle. That means P lies on a circle whose radius is root 2r. That means P is at a distance from Q equal to r root 2. If r is the radius of the circle, then PQ must be r root 2. R root 2, as you can see, is 2 into 2, 4 plus 3 root 2. 4 plus 3 root 2 is PQ, right? Now from this point P, which lies on the director circle of the circle, two tangents are drawn, PA and PB. And there is another circle that is created, as you see in the red. You see in the red, right? And this circle is supposed to be touching the blue circle and the pair of tangents PA and PB. What can you say of the pair of tangents drawn from P to the circle? They must be perpendicular. Why? Because P lies on the director circle. P lies on the director circle. And very clearly this is 90 degrees. So you see this angle would be 45. This angle will be 45. I want to be able to find the radius of this circle drawn in red, whose center is O. This is what I want to be able to find. One thing, do I know PQ? Yes, PQ is root 2 times R, right? I want to find R1, the radius of the circle in red. That's what I want to be able to do. Now, what is OP? Do you realize? Look at this triangle. This is P, O, and this is, let me call this T. T. This is 90 degrees. This is R1, and this is 45 degrees, as you can see, right? So very clearly OP would be R root 2. So if this is R, this is R, OP would be R root 2. So I know OP. OP is R root 2, right? And to that I add OS. What is OS? OS is R1. So sorry, OP is R1 root 2. Let me call this R1, R1. So this is R1 root 2, R1 root 2. So OP is R1 root 2, OS is R1, and SQ. What is SQ? SQ is R, the radius of this given circle. Now if I add all of this, so this is R. If I add all of this, R1 plus this length, which is R1 root 2, which is R1 root 2, R1 root 2. See OP, which is R1 root 2, plus SQ, which is R, the radius of the circle. Then I get PQ, which is R root 2, which is PQ, which is R root 2. That's what I get, right? R is this. I hope all of you understand this. See, this is the circle. R1 is the radius of the circle in red. OP is very clearly then R1 root 2. R1 root 2 plus R1. R1 root 2 plus R1 plus R will be PQ. But PQ is R root 2 because P lies on the director circle of this circle of radius R. So this is what I get. And therefore R1 into 1 plus root 2. R1 into 1 plus root 2 is R into root 2 minus 1. That's what I get. R1 then is what? R, which is 3 plus 2 root 2 into root 2 minus 1 divided by root 2 plus 1. That's what I get. We could simplify this. So how much does it turn out to be? R1 equal to, let me rationalize the denominator, multiplying with root 2 minus 1, root 2 minus 1. So I get like a 3 plus 2 root 2 2 plus 1, 3 minus 2 root 2. Right, if I multiply this, root 2 minus 1 whole square, it would be 2 minus 2 root 2 plus 1 divided by 1. So this is like 9 minus 8, which is 1. So the radius of the circle is going to be 1. So this is more of geometry and less of coordinate geometry. But then of course you needed to know what a direct circle was and so on and so forth. But otherwise a fairly simple problem. Yes or no? Thank you so much. This problem is about a circle x minus 2 whole squared plus y squared equal to 4. Right? Obviously it's a circle with center 2, 0 and radius 2, as you can readily see. Now, we are trying to look at another circle that passes through 5, 6. We are looking at a circle that passes through 5, 6 and is touching the circle Now very clearly you can see 5, 6 is a point outside the circle. Why? Because if you plug in x equal to 5 here, y equal to 6 here, then 9 plus 36, 45 minus 4, which is greater than 0. 5, 6 is obviously a point outside this given circle, right? Now what we want to find is 1, the radius of the smallest circle passing through 5, 6 and touching this circle, and the radius of the largest circle, this is the largest circle, passing through 5, 6 and touching the circle. Very clearly, this will give me the smallest value of the radius of the required circle, which I refer to as R1. This will give me R, the radius of the largest circle passing through 5, 6 and touching the circle. This circle evidently will touch this circle externally. This circle will touch this circle, rather this circle will touch this circle internally, right? So this will give me R max, maximum radius of this circle, and that's going to be referred to as R2. Now, as simple as this, D is the distance between 2, 0 and 5, 6. D is the distance between 2, 0 and 5, 6, which is from distance formula, as you can see, 5 minus 2 whole squared plus 36, which is 3 root 5, right? Now, if small r is the radius of the required circle here, which is R1, the smallest possible circle, this is the smallest possible circle satisfying the given conditions, then very clearly capital R plus 2r, this is r and this is also r, must be equal to d, right? What does this give me? Small r as d, which is 3 root 5 minus the radius of this circle, capital R, which is 2 by 2. That's R1. Right? This will, in this case, R will be R1. R will be R1. So when you solve for R1, you will get D minus R by 2. What about this? In this case, the distance this is 3 root 5, right? So D, 3 root 5 in this case would be, as you can again see, what is this distance? 3 root 5. So here we have 2R minus capital R as D. How? Look. This distance is r plus r 2r, right? This distance, this whole distance is small r. This whole distance is small r, right? C2 to P is small r plus r. That is 2r, isn't it? This whole distance from P to say Q. From P to Q is 2r, right? And from 2r, if I subtract capital R, I'll get D. From 2R, 2 times small r, this is 2 times small r, I subtract capital R, I'll get D. So that will give me small r equal to D, which is 3 root 5 plus capital R, which is 2 divided by 2. And this small r is referred to as R2, the radius of the biggest circle. So call it R equal to R2. So I know R1, I know R2. What we need to find in this problem is the value of R1, R2, which is 3 root 5 minus 2 into 3 root 5 plus 2 divided by 4. 9 5s are 45 minus 4, 41 by 4. So the value of R1, R2 is going to be 41 by 4. So what was given in the problem? Given a circle x minus 2 whole squared plus y squared equal to 4, a circle with center 2, radius 2, 0 and radius 2. We want to find the smallest and the largest circle touching this circle and passing through 5, 6. This is the circle. This is the smallest circle passing through 5, 6 and touching the circle. The important thing is, in this case or this case, the center of one circle, the center of the other circle, required circle, and the point 5, 6, they have to be collinear points. And this case will give me minimum value of the radius of the required circle. This situation will give me maximum value of the radius of the required circle. Yes or no? Thank you so much. Bye. Right. So another problem for you. There is the circle x square plus y square minus 9 equal to 0. And there is a line x plus y equal to 3. Right. Now I select a point on this line and I draw pairs of tangents PA and PB. Now AB is the chord of contact. Now if I select different points on this line, I get different ABs. I want to find out if there is a point through which all these ABs pass through, whether these ABs produced by different P's will produce different ABs, whether they are concurrent lines or not. Now, what's AB? AB is the chord of contact with respect to P, right? Any P on this line can be selected as, if you select X is H, Y will be like 3 minus H. Then I can find the equation of the chord of contact in terms of the parameter H, right? Now, in this case, if P is of this form, it will always lie on this line, right? So, the equation of AB in terms of the chord of contact is T equal to 0, as we know. So, which is like X into H plus Y into 3 minus H minus 9 equal to 0, right? That's the equation of the chord of contact. T equal to 0, right? Xx1 plus yy1 minus 9 equal to 0. Now, which could have been written as 3y minus 9 plus H into X minus Y equal to 0. That means H is my parameter. If any line can be written as L1 plus lambda L2 equal to 0, where lambda is a parameter, then that line must pass through the point of intersection of L1 equal to 0 and L2 equal to 0. That means this line is like a L1, this is like a L1 plus, this is like my lambda, and this is like my L2. That means AB can be written as a linear combination of two fixed lines, L1 equal to 0 and L2 equal to 0. That means 3y minus 9 equal to 0, which is L1 equal to 0, and L2, which is like a X minus Y equal to 0, which gives me, and the point of intersection of these two lines is like Y equal to 3 and X equal to Y. That means X equal to Y equal to 3. That means all these ABs will necessarily pass through a point 3, 3, and very clearly 3, 3 must be a point outside. 3, 3 is a point outside because 9 plus 9, 18, minus 9 is a positive number. So 3, 3 is a point outside this circle. That means the different P's will end up producing different ABs, but all the ABs produced will necessarily pass through the point 3, 3. That's the rule of the game. Thank you so much. We have two circles. S, which is x squared plus y squared minus 12x plus 35 equal to 0, and S prime, which is like a x squared plus y squared plus 4x plus 3 equal to 0. And what we are looking at is a circle orthogonal with the two circles. We are looking at a circle which is orthogonal with the two circles. Now, what we've learned from our concept session is the fact that if there is a circle which is orthogonal with two given circles, then the center of the circle, will lie on the radical axis of these two given circles. Given two circles and a third circle which is orthogonal with these two circles, then the center of that circle will lie on the radical axis of these two circles. So first of all, the radical axis of these two circles, this is the radical axis, RA, radical axis. And we know that the equation of the radical axis is like a S minus S prime equal to 0. That's the equation of the radical axis of two circles. S minus S prime equal to 0 means minus 16x and 35 minus 3, 32 equal to 0. That means x equal to 2. That means the equation of the radical axis is x equal to 2. The center of that circle, which is orthogonal with these two circles, lies on this line x equal to 2. Now, obviously, the center could lie anywhere on this, right? Of the very many circles whose center lies on the radical axis and orthogonal with these two circles, like we've learned, the circle with the smallest radius, the smallest circle will have its center, at this point, call it C, will have its center at this point C, right? Now, so all that I need to do is, I need to find the intersection of the radical axis with the line joining the centers. That will be the center of that required circle. Now, easy to see. uh, realize that the line joining C1 and C2, so C has x coordinate 2 because it lies on the line x equal to 2. This is the line joining C1, C2, which is a point on the x-axis. See, x is y0, y0. So this is really the x-axis. This is really the x-axis. X-axis means 0 here, right? That means the required circle has center. The minimum possible circle will have its center at 2, 0, and that radius of that circle would be the tangent drawn from C to any one of the two circles. This length, say CP, that's the length L of the tangent. Now, how do I find the length of the tangent from 2, 0 to this circle? So, that will be given by root S1, right? L will be given by root S1. Put x equal to 2 and y equal to 0. X equal to 2 minus 24 plus 35, 39 minus 24 root 15. So L equal to root 15. So L will be the radius, root 15 would be the radius of the minimum circle. Minimum circle orthogonal with these two circles. Smallest circle orthogonal with these two circles. Its center would be 2, 0. So what would be the equation of that circle? That's going to be x minus 2 whole squared plus y squared equal to 15, root 15 whole square. That's the smallest circle orthogonal with these two circles and of smallest possible radius. Any other circle, so in fact there are a family of circles orthogonal with these two circles and their centers lie on this radical axis. Yes or no? Thank you so much. So the next problem is about a point P 5, a point R 5, 8. Right? And there is a circle S equal to 0. A circle S equal to 0 whose radius is 5 units. This is a circle S equal to 0 centered at some point C, H, K, we still do not know. And such that from this point R, we draw pairs of tangents RP and RQ to this circle whose center is unknown. Right? Now, there is a circle that passes through P, R and Q. And the center of that circle, which is the circumcenter of triangle PQR, the circumcenter of triangle PQR is 5, 3. The circumcenter of triangle PQR is 5, 3. And we want to be able to find, the equation of this circle, right? Now, how does one do that? Now, one very basic observation, realize that, you know, this is 90 degrees, radius perpendicular to the tangent. This is 90 degrees. So which means this PRQC is a cyclic quadrilateral. PRQC is a cyclic quadrilateral. Is a cyclic quadrilateral because a pair of opposite angles is supplementary, so it's a cyclic quadrilateral. That means the circle that passes through P, Q and R, the circle that passes through P, R and Q will also pass through C because this is a cyclic quadrilateral. So this time the circumcenter of triangle PQR is also the center of the circle that passes through PRQC because the same circle that passes through PRQ will also pass through C because they are concyclic points. Why are they concyclic points? Why are PRQC concyclic points? Because PRQC is a cyclic quadrilateral. Why is it a cyclic quadrilateral? Because this plus this is 180 degrees. Good. So which means it's not just PQR that the required circle passes through. The circle circumscribing PRQ passes through. It also passes through C. Now the center of that circle passing through PRQ and C must lie where? Where must it lie? Realize that this is 90 degrees, so this must be angle in a semicircle. So RC must be the diameter of the circle, circle of PQR. RC must be the diameter. That means the center must be halfway between R and C. The center of the circumcircle of PQR, which is 2, 3, must be halfway between R and C. Right? The center, because CR will be the diameter, midpoint of CR would be the center of the circumcircle of triangle PQR. Now, I can find H, K because M is the midpoint. 2 must be H plus 5 by 2 from section formula. And 3 must be K plus 8 by 2. That gives me H equal to minus 1, as you can see, and that gives me k equal to minus 2. That means I now know the center of the circle, minus 1 comma minus 2, minus 1 comma minus 2. Yes or no? Right? If I know the center of the circle, I know the radius of the circle. Can I find the equation of the circle? Yes. It's like a x plus 1 whole squared plus y plus 2 whole squared is 25, or that will give us like a x squared plus y squared, and then there is a plus 2x plus 4y, 4 and 1 5, minus 20 equal to 0. That's the equation of the required circle. I hope all of you understand everything that I have said here, right? Make sense? So much for this problem. That's all. Bye bye. Another easy problem. We have a circle x square plus y square minus 3x minus 4y minus 4 equal to 0. And there is a chord AB. That is known to pass through the center of the circle. That is known to pass through the origin O. Hey, origin O is inside the circle. You see that? Put x equal to 0, y equal to 0, x equal to 0. It turns out to be a negative number. So origin obviously is a point inside the circle. Now through O, how many chords can be drawn? Infinity of chords can be drawn. But we are interested in a chord that passes through O, a chord AB that passes through O such that O divides AB in the ratio 1:4. See, what is required is O dividing AB in the ratio 1:4. That means if I choose AO as lambda, then OB will be say some 4 lambda. Lambda we do not know, but surely lambda is a positive number, right? So in the ratio lambda is to 4 lambda, 1:4, right? Such is the chord. We want to find the equation of this chord. Obviously, you know, you'll be able to visualize that there will be 2 such chords. And if I know the point through which the chord passes, all that we need to know is the slope. What's the blueprint of the problem? The blueprint of the problem is that I want to find the slope of AB. If the slope of AB is m, this is a line passing through the origin, so it must be of the form y equal to mx. So I need to know m. In fact, there will be 2 values of m. You want to critically analyze why so. Now, if I can find the distance of the center of the circle from AB, that is h if I can find, right? Then using the fact that distance of a point from a line y equal to mx is h, a known number, I'll be able to find m. So my task eventually is, I'm redefining the problem in terms of trying to find h, the distance of the center from this chord, right? The perpendicular distance from the center of the circle to this chord AB, that is h, is what I want to find. Now that's a fairly simple proposition. I'll apply Pythagoras theorem. First of all, distance between O and C. Distance between O and C we have computed using distance formula, root 9 by 4 plus 4, that is 5 by 2. That's OC, is known to me. Now, to this triangle, say CMO, if I apply Pythagoras theorem, then very clearly h squared plus OM squared. H squared plus OM squared. What is OM squared? OM squared is AM. See, this entire length AB is 5 lambda. So AM will be 5 lambda by 2. Yes or no? AM will be 5 lambda by 2. Do you realize that? AM would be 5 lambda by 2. Right? And AO is lambda. So AM is 5 lambda by 2. Right? And from which if I subtract lambda, then I get OM. Right? AM is lambda and M is the midpoint. AM is 5 lambda by 2. So what's my OM? OM is going to be 5 lambda by 2. 5 lambda by 2 minus lambda. That is 3 lambda by 2. Is 3 lambda by 2. Right? So h squared plus OM squared. OM squared is 5 lambda by 2 minus lambda, which is 3 lambda by 2. 3 lambda by 2 whole squared is d squared. D squared is 41 by 4. No, sorry, is 25 by 4. Is 25 by 4. Right? That's one. Now, look at, so that's my equation 1. Let me look at triangle CAM. Apply Pythagoras theorem to triangle CAM. Again, h squared plus this length AM, which is 5 lambda by 2. 5 lambda by 2 whole square is equal to r squared. R squared is radius of the circle, which is 41 by 4. 2. I need to solve for h essentially. So let me first subtract and obtain lambda, and then I'll plug in the value of lambda, or I could directly eliminate lambda. However, it does not matter. So if I say 25 minus 9, 16, 16 by 4 lambda squared. If I subtract 2 minus 1, 9, 16 by 4 lambda squared is 16 by 4, or I get lambda equal to plus, I'll take positive value, lambda turns out to be plus 1. Plus minus 1, but I'll reject the value minus 1, lambda equal to plus 1. So if I plug in lambda equal to plus 1 here, I get h equal to 25 by 4 minus 9 by 4. That's my h squared. So 16, 25 by 4 minus 9 by 4. 9 by 4, 16 by 4, 4. H turns out to be 2. H turns out to be 2. That means the required chord is at a distance h equal to 2 units from the center of the given circle. That means the distance of the line y equal to mx from this point is, what we have is, this is the line y equal to mx. That means I could have written this as mx minus y equal to 0, and its distance from the point 3 comma 2, 3 by 2 comma 2 is equal to 2 units, cm. I use this fact to obtain the value of m. So perpendicular distance of 3 by 2 comma 2 from this line is what? Put x equal to 3 by 2, so 3m by 2 minus y equal to 2 divided by root 1 plus m squared. That must be equal to h, which is 2 units. So I just need to solve for m now. If I obtain the value of m, you'll see that you'll get a quadratic in m, and you'll get 2 such chords. So if you allow me to remove the clutter from here, or maybe from here, let me solve. So I have like a 3m minus 4 mod of this divided by root 1 plus m squared is 2 to 2, 4, or squaring, I get 3m minus 4 whole squared, right, equal to 16 into 1 plus m squared. Now realize 16 and 16 will get cancelled, so which is now 16m squared minus 9m squared is like a 7m squared, and then 16 getting cancelled, and then I have 24m, so plus 24m equal to 0, or that gives me m into 7m plus 24 equal to 0. That will give me m equal to 0, m equal to minus 24 by 7. That means the 2 chords would be, put m equal to 0, that will give me y equal to 0. Put m equal to minus 24 by 7, that will give me y equal to minus 24 by 7 x, or that could have been rewritten as 24x plus 7y equal to 0. So these are 2 possible lines, y equal to 0, which is the x-axis, and 24x plus 7y equal to 0, that's the other line. And now, you know, you should have visualized that there will be 2 lines. If this is a circle, this is the origin, and if divides it in the ratio 1:4, and this is the center of the circle, there could have been a chord like this, and there could have been a chord like this, say, for example, right? There could have been 2 chords passing through O at a distance, 2 units from the center. These would have been the 2 chords, yes or no? So I think all of it makes sense to you. Let's move to the next problem. Thank you so much. Bye-bye. So this problem, again, it will make great sense to understand what's happening. It's a simple problem, but what's essentially given is a circle whose center is h comma k unknown, and this center lies on this line 3x plus 4y equal to 5. There is a point P outside the circle, and from this point a pair of tangents are drawn, x plus 2y equal to 3 and 2x plus y equal to 3. That's a pair of tangents drawn from an external point to this circle, right? We want to be able to find the coordinates of the center of the circle. Given that this x plus 2y equal to 3 and 2x plus y equal to 3 are pairs of tangents drawn to the circle. Now, very clearly the center h comma k lies on this. Also notice that PC, C will also lie on the angle bisectors between the two lines, either internal or external, right? C would lie on any of the two angle bisectors between these two lines. Yes or no? This PC would be an angle bisector between these two lines, and there are very clearly two angle bisectors between these two lines. So between these two lines, how does one find the angle bisector? Minus 3 divided by root 5 equal to plus minus 2x plus y minus 2x plus y minus 3 divided by root 5, right? So the center C must lie on any one of the two lines. Let's obtain the two lines. One, if I take the plus sign, I get like a x plus 2y minus 3 equal to 2x plus y minus 3. On taking the plus sign, that gives me like a minus x plus y equal to 0. So this is like a line x equal to y, one possibility. So C could lie on x equal to y, right? Or the other possibility is, if I take the minus sign out of here, if I take the minus sign, then I get like a x plus 2y minus 3 equal to minus of 2x plus y minus 3. Or that gives me like a 2x plus x, 3x plus 3y equal to 3 plus 3, 6, or x plus y equal to 2. Let's check the calculations once again. So x plus 2y minus 3 equal to minus of 2x plus y minus 3. So that gives me like a 2x plus x, 3x, and there is a 2y plus y, 3y, and then there is plus 3 plus 3, 6, or x plus y equal to 2. Right? That's the second possibility of PC. So PC could lie on x equal to y or could lie on x plus y equal to 2. So, and PC also satisfies this equation. I'm sorry, C, the coordinates of C will satisfy this equation, 3x plus 4y equal to 5. And C would satisfy this or this condition. Suppose I take 1, C satisfying 1, so x equal to y, and that the intersection of 3x plus 4y equal to 5 and PC will give me the coordinates of C. So what does this give me? If I plug in x equal to y, then I get like a 3x plus 3y, 4y equal to 5, x equal to 5 by 7, and y equal to 5 by 7. So C could be 5 by 7 comma 5 by 7. That's one possibility. Or the other thing is C lying on this. That means C satisfying this condition, 3x plus 4y equal to 5. And C lying on the other angle bisector, x plus y equal to 2. X plus y equal to 2. Now what does this give me? Let me solve for this. So this is like a 3x plus 4 into y is like a 2 minus x equal to 5. I'm solving these two equations to get the coordinates of C. Or I have like a minus x equal to 5 minus 8. 5 minus 8, which is minus 3, right? 3x minus 4x minus x equal to 5 minus 8 minus 3. So that gives me x equal to 3. If x is 3, very clearly y is minus 1. X is 3, y is minus 1. So the other possibility for C could be 3 comma minus 1. So C could either be 3 comma minus 1 or C could be 5 by 7 comma 5 by 7, depending on which of the two angle bisectors C would lie in, right? Between PA and PB there is going to be two angle bisectors, and we found the equation of the two angle bisectors. Now C could lie on either this angle bisector or this angle bisector, and it's given that C lies on this line anyways. So solving the equation of the angle bisector along with this will give me the intersection, which is the point C. Thank you so much. Bye. So here we have the equation of a circle given to us, and we want to find the condition that this circle passes through 3 quadrants but does not contain the origin. Passing through 3 quadrants but does not contain the origin. That means what we want is, we want this circle to be something like this, say. We want this circle to be something like this. It could have been like this. For example, in this case it passes through 3 quadrants. Do you realize that? First quadrant, second quadrant, and fourth quadrant, and origin is not contained here, right? Or I could have had something like this. Here also it passes through 3 quadrants. Realize second, third and fourth quadrant, but origin is not contained here. And so on and so forth. Now, in any case, what is important is that the intersection with the x-axis must be distinct roots, intersection with the y-axis must be distinct real roots. Intersection with the x-axis must be distinct real roots, intersection with the y-axis must be distinct real roots, and the origin must lie outside this curve. So first of all, you know, h has to be 0. Otherwise it cannot represent a circle, so h has to be 0. And its intercept with the x-axis, how do you deal with its intercept with the x-axis? Put y equal to 0. And that must have real and distinct roots. Y equal to 0 means x squared plus 2gx plus c must be 0. And its discriminant must be greater than 0 because I must have distinct values of x1 and x2. That means g squared minus c must be greater than 0. 4g squared minus 4c greater than 0, or g squared minus c greater than 0. That's one condition. And distinct real values of y, intercepts with the y-axis, put x equal to 0. So if I plug in x equal to 0 here, I get a quadratic in y squared plus 2fy plus c equal to 0. It should give me two distinct values of y1 and y2. That means discriminant greater than 0. That means f squared greater than c. F square, 4f square minus 4c greater than 0. So f squared greater than c. And now the origin outside the curve. That means if you plug in x equal to 0, y equal to 0, I must get a positive number. So put x equal to 0, y equal to 0, 0, 0, 0, 0, I get c. That must be positive. So origin must produce a positive sign on this expression for the origin to lie outside the curve, origin not contained inside the curve. Right? So f square greater than c, g square greater than c, and c greater than 0. This is what we must have. Yes or no? Thank you so much. Bye. I hope you're getting acclimatized with the basic tenets, the basic ideologies and ideas related to the geometry and algebra of circles. In that context, here I present another problem across to you. It's about a circle x square plus y square is a square, whose center C1 is 0, 0 and whose radius is a. And there is another circle x square plus y square minus 2ax is 0, whose center very clearly is a0, whose radius is a. Now, what we are doing is, we are drawing chords to this circle. This circle. This is the circle x square plus y square equal to a square. We are drawing chords AB. And we are drawing only those chords of this circle that touch this circle, That means are tangential to this circle, right? We are drawing those chords of the circle that touch this circle. And for those chords, we are drawing tangents at the endpoints. And these tangents meet at P, H, comma, A. For different ABs of this circle that touch this circle, I'll have different HKs. I want to find the locus of the points P, H, comma, K. So first of all, if I take any point H, comma, K, then can I find the equation of AB? Yes, I can find the equation of AB. AB is the chord of contact of this circle with respect to P. So then chord of contact of this circle with respect to P, this minus a squared is 0. That means I end up getting AB as hx plus ky minus a squared is 0, right? And if this line AB is a tangent to this circle, right? This AB is a tangent to this circle whose center is C2, a comma 0, this is AB, and it touches this other circle. That means the distance of this line from the center of the circle must be equal to the radius R2 of the circle. That means the distance of A0, the center of the circle from AB, that means from AB must be equal to the radius A. So distance of AB from A0, what is that? Put x equal to A, y equal to 0. So mod of HA minus A squared divided by root h squared plus k squared, and that must be equal to the radius R2, which is A. That must be the condition met by this point P, right? And now what I can do is I can simplify matters. So 1a I can cancel. So this is 1. So then I square, I end up getting h minus a whole square is h square plus k squared, right? H square will get cancelled with h squared. Then I have like a k squared equal to minus 2ah plus a squared. K squared equal to minus 2ah plus a squared. And then I generalize. I end up getting, put k x equal to h and y equal to k. So to get the locus of P, generalize this. So y squared equal to minus 2ax plus a squared. That's the locus. Which could have been written as a into a minus 2x. That's the locus. Yes or no? Thank you so much. Bye-bye. This problem, we have a circle x squared plus y squared equal to a squared, which is very clearly a circle with center 0, 0 and radius a, right? And we draw an isosceles triangle. ABC with B and C being 75 degrees. Base angles B and C being 75 degrees, and therefore the angle at A being 30 degrees. That means angle BAC is 30 degrees. And the point A has coordinates a comma 0. We want to find the coordinates of B and C. Now that's an easy problem to look at. How? Look, essentially, AD, realize this is really the x-axis. Right? And OA is A units, the radius of the circle, and OB will also be A units, the radius of the circle, A and A. Now, each of this entire angle at A is 30 degrees, and therefore AD being an altitude will bisect this 15 degrees, right? And if this is 15, this is an isosceles triangle. Would you not want to believe that this is also 15? So what is theta? Theta very clearly exterior angle, sum of two interior opposite angles, 15 plus 15, which is 30 degrees, right? And OB is A. So what is BD? BD is going to be A sine theta. A sine theta means A into sine 30 degrees, A by 2. That means if BD is A by 2, that means the y coordinate of B must be A by 2. What about the x coordinate of B? Look, what is OD? OD is A cos theta. A cos theta means A cos 30 degrees. A cos 30 degrees means A root 3 by 2. That's OD. So what is the x coordinate of D? X coordinate of D is minus A root 3 by 2, because it's to the left of the origin. Minus A root 3 by 2, 0 are the coordinates of D. So what about B? B and D will have the same x coordinate, minus A root 3 by 2. And y coordinate would be BD, which is A by 2. And very clearly, C then would have the same x coordinate, minus A root 3 by 2. And its y coordinate would be negative of the y of this, because this is above the x-axis, this is below the x-axis by an equal amount. So it's going to be minus A by 2. So the coordinates of B and C would be these as shown. This one problem really worth sharing. We have the circle S equal to 0, x square plus y square plus ax plus by plus c equal to 0, and another fixed circle x square plus y square plus a prime x plus b prime y plus c prime equal to 0, which is s prime equal to 0. And there are two lines. There is one line ax plus by plus c equal to 0 cutting this circle at P and Q, and there is another line a prime x plus b prime y plus c prime equal to 0 cutting this circle at R and S, right? Now what's given is that P, Q, R, S are concyclic points. Are concyclic points. We want to be able to show that this determinant A minus A prime, B minus B prime, C minus C prime, capital A, capital B, capital C, and capital A prime, capital B prime, capital C prime, that must be 0. Alright. So if PQRS are concyclic points, we can easily imagine a circle that passes through PQRS. This dotted circle is the circle that passes through PQR and S, right? Very clearly, AX plus BY plus C equal to 0 is a common chord of S and S prime. AX plus BY plus C equal to 0 is a common chord of S and S prime. So it's, do you also realize it could also be looked upon as the radical axis of S and S double prime? Of S and S double prime, this is the radical axis, right? Radical axis of S and S double prime is what? This line, AX plus BY plus C equal to 0. Equal to 0. Also, A prime X plus B prime Y plus C prime equal to 0 then is also, which is a common chord, therefore also a radical axis of S double prime and S equal to 0. So radical axis of S double prime and S prime. S double prime and S prime is this line, which is like A prime X plus B prime Y plus C prime equal to 0. Right? And then, would you not also want to believe that there is a radical axis of S and S prime? Radical axis of S and S prime is going to be given by S minus S prime equal to 0, right? So, radical axis of S and S prime is going to be given by S minus S prime equal to 0. S minus S prime equal to 0 means this minus this, which would be like A minus A prime into X plus B minus B prime into Y plus C minus C prime equal to 0, right? So we have three circles, and these are the three radical axes of the three circles taken in pairs, yes or no? These are the radical axes of the three circles taken in pairs. And therefore, what we know out of properties of radical axis of three circles taken in pairs, the radical axis of 1, 2, 2, 3 and 3, 1 would be concurrent lines. And they meet at a point O, which is the radical center for the three circles. Yes or no? Right? So radical axis of 1 and 2 is this. Radical axis of 2 and 3 is this. Radical axis of 1 and 3 is this minus this, which is this. And the three radical axes of the three circles taken in pairs are concurrent lines. They meet at the radical center. Therefore, this is the third radical axis. 1, 2 ka radical axis. This is 1, 2. This is 2, 3. And this is 1 and 3. These are the three radical axes. They are concurrent lines. Right? That means this line, and this line. If they have to be concurrent lines, if three lines are concurrent, then the condition for concurrence is precisely this. A minus A prime, B minus B prime, C minus C prime, which is the first row, and A, B, C, which is the second row, and A prime, B prime, C prime, which is the third row. That determinant must necessarily be 0. Yes or no? So I thought this was an interesting problem, and it gave you a real application of concurrence of radical axis of three circles in pairs. I hope you enjoyed everything about it. Thank you so much. Bye. Now, refer to this problem, which otherwise looks like a problem on geometry. We have a circle passing through C of a rectangle. This is a rectangle ABCD. This is a rectangle ABCD, and there is a circle passing through C that's given. There is this circle passing through C that's given in the problem. Now, AB and AD touching the circles. AB and AD being tangents to the circle. And the points of tangency, let's say, call them M and N respectively. All right. Now, distance of MN. This is MN. Distance of MN. This is MN. From C is given to be 5 units. We want to find the area of this rectangle ABCD. We want to be able to find the area of this rectangle ABCD. So first things first, what we do is, the two lines that are touching the circle, let me call them the X and the Y axis. AB along the X axis, AD along the Y axis. And M and N the points of tangency. Now notice that the center of the circle, if R is the radius of the circle and if it is touching both the axes, then this would be r, the x coordinate. If r is the radius of the circle, this would be r and this would be r. Yes or no? R comma r would be the center O of the circle. R comma r would be the center O of the circle. Does it make sense? And if r comma r is the center O of the circle, very clearly this point of tangency M is going to be r comma 0, and this point of tangency N is going to be 0 comma r, where r is the radius of the circle. Then what's the equation of the circle? Equation of the circle is x minus r whole squared plus y minus r whole squared equal to r squared. That's the equation of the circle, right? Now, what is it that we have? We have distance of Mn from C. Now B we refer to as P0 and D we refer to as 0Q. So the point C would be P comma Q. The point C would be P comma Q, right? And what's given is distance of P comma Q from Mn is 5 units. We want to find the area of the rectangle ABCD. Now we have things in place, right? What's required is equation of Mn so that I can compute the distance, perpendicular distance of C from Mn. What's the equation of Mn? Look, its x-intercept is r, y-intercept is r. So the equation of Mn is very clearly x by r plus y by r equal to 1. X by r plus y by r equal to 1, or I can write this as x plus y minus r equal to 0. Right? That's the equation. Now distance of PQ from this line is what? Distance of PQ from this line, x plus y minus r, is p plus q minus r divided by root 2. And that's given to be 5. That's given to be 5. All right. We want to be able to find the area of the rectangle. That means we want to find the value of PQ. We want to find the value of PQ given all of this. So first of all, I have still not used the fact that PQ is a point on the circle, right? If PQ is a point on the circle, PQ must satisfy this equation 1. So if PQ satisfies equation 1, we have like a P minus R whole squared plus Q minus R whole squared equal to R squared. That's what we get. Or we end up getting P squared plus Q squared minus 2R into P plus Q, and then 2R squared minus R squared, so plus R squared equal to 0. That's what we get. We want to obtain the value of PQ because we know the value of mod of P plus Q minus R. We want to obtain the value of PQ. Now again, I write this as P plus Q whole square minus 2PQ. I'll put that minus 2PQ somewhere else. Minus 2R into P plus Q plus R squared, and then I do a minus 2PQ here equal to 0. That's what I do, right? So now do you realize it's A square minus 2AB plus B squared, and this minus 2PQ is adjusted because I wrote P square plus Q squared as P plus Q whole squared minus 2PQ, or I end up getting P plus Q minus R whole squared equal to 2PQ. Right? Now if I take the square root of both sides, then on taking the square root of this will root x squared is mod x, right? So square root of this would be mod of P plus Q minus R, that's equal to root 2PQ, right? Very clearly, mod of P plus Q minus R is 5 root 2, is 5 root 2. 5 root 2. Mod of P plus Q minus R is 5 root 2, so which gives me PQ equal to root 2 will get cancelled equal to 5. PQ equal to 5. So the area of the rectangle is 5 square units. The area of the rectangle ABCD is 5 square units. I hope all of you understand everything that I've said here, right? So on taking the square root, mod of P plus Q minus R is what I get, is root 2 PQ. PQ is what I seek. So root PQ is 5. That's given. Let me just fix this. Root PQ would be 5. So PQ would be 25. PQ would be 25. So the area of the rectangle ABCD is 25 square units. Is 25 square units. Right? So essentially, a problem on geometry converted into a problem on coordinate geometry, and without too much of involvement of brains, you could just do things mechanically and arrive at the answer. But I hope you understand everything that I've communicated here. Thank you so much. Bye. look at this problem. Two circles, one x squared plus y squared minus 2x minus 2y plus 1 equal to 0, and another circle x squared plus y squared minus 16x minus 2y plus 61 equal to 0, right? And a straight line y equal to 2x plus a, where a is a parameter. A is looked upon as a parameter. What we want is, we want to find the range of the parameter a. We want to be able to discover the range of a, so that this line lies between the two circles and does not intersect or touch any one of the two circles. This line lies between the two circles, does not intersect or touch any of the two circles. So what all conditions would be required? So first of all, the centers C1 and C2 must be on opposite sides of the line. That means the coordinates of the centers must produce opposite signs on the line, right? So let me rewrite the line as 2x plus y plus a equal to 0. Now, what value does 1 comma 1 give to this expression? 2x minus y, right? 2x minus y plus a equal to 0. What does 1 comma 1 do to this expression? It produces a value 2 minus 1 plus a. What does 8 comma 1 do to this expression? 2x minus y plus a, it produces a value, 8 comma 1 produces a value 16 minus 1 plus a, right? These are the two values produced by the coordinates of the centers on this expression, and these centers have to lie on opposite sides of the line. So the signs of these two numbers must be opposite. The signs of these two numbers must be opposite because the centers lie on opposite sides of the same line, and therefore the coordinates of the center will impart to this expression opposite signs. That means one of the two must be positive, the other one must be negative. That means into this must be less than 0. That's the first requirement. And of course, the other requirement would be if this line is not to intersect or touch this circle, then the distance of the center from this line must be greater than the radius. If it is not supposed to touch or intersect this circle, then the distance of the center from this line must be greater than the radius of this circle, right? We'll have to put it all together to obtain the range of a. So first of all, let me look at this, where the centers must lie on opposite sides of the line, which is like, this would eventually give me like a plus 1 into, this is like a minus 15 is less than 0. A plus 15 is less than 0. And from wavy curve, look at this, minus 15 minus 1. The wavy curve for a plus 1 into a plus 15 is this. Very clearly, in order that this expression is negative, a must lie in the interval minus 15 to minus 1. So a belongs to minus 15 to minus 1 from wavy curve, right? That's the first requirement. But that's not enough. That will only ensure that the centers lie on opposite sides of the line. What's the other requirement? The other requirement is that the distance of the center from this line greater than the radius, distance of the center from this line greater than the radius of the circle, right? So D1 greater than R1. Distance of 1, 1 from this line is what? Distance of 1, 1 from this line is 2 into 1, 2 minus 1 plus a by root 5, root a square plus b square. Distance of 1, 1 from this line, and that must be greater than the radius of this. The radius of this, as you can see, is 1. Radius of this is 1, greater than 1. That's 1. Also, distance of 8, 1 from this line must be greater than R2. R2, the radius of the circle you can obtain is 2. So distance of 8, 1 from this line is 16 minus 1 plus a by root 5. That in turn must be greater than the radius 2. So this 1, a has to belong to this interval. 2, a must satisfy both these conditions. I'll have to put together all of these, right? So let me look at each one of them independently. This will give me mod of a plus 1 greater than root 5, which means a plus 1 greater than root 5, or a plus 1 less than minus root 5, right? This gives me a greater than root 5 minus 1, or a less than minus 1 minus root 5, right? That's one. We'll summarize all of this. 1. Look at this. Mod of a plus 15 greater than 2 root 5, which will give me two conditions: a plus 15 greater than 2 root 5 or a plus 15 less than minus 2 root 5, right? So this in turn says a greater than minus 15 minus 2 root 5. From this condition, a greater than minus 15 minus 2 root 5 or a less than minus 15 minus 2 root 5, right? This is the second set of conditions. Now we have this, this and this. Let's put it all together. So first of all, I know that a must belong to minus 15 to minus 1. So let me have my processing window as minus 15 to minus 1. Surely in this interval. Now, a greater than root 5 minus 1? Now that's not possible, because root 5 minus 1 is a positive number and it will lie to the right of minus 1. But we'll have to deal with values of a that strictly lie in this interval, minus 15 to minus 1. So this condition is ruled out. And a less than minus 5 minus root 5, minus 1 minus root 5 is a number here. Minus 1 minus root 5 is a number here. That means a has to be to the left of this. Minus 1 minus root 5. A has to be to the left of this. Right? Now let's look at this. A less than minus 15 minus 2 root 5. Now minus 15 minus 2 root 5, minus 15 minus 2 root 5 is a number here. So a cannot be less than minus 15 anyways. So this condition is ruled out. But a greater than minus 15 minus 15, let me just see, a greater than 2 root 5 minus 15, 2 root 5 minus 15, and a less than, so this has to be written as a greater than 2 root 5 minus 15, 2 root 5 minus 15, and this is a less than minus 2 root 5 minus 15. Now, a less than minus 2 root 5 minus 15 is not possible, because that's to the left of minus 15. But a greater than minus 15 plus 2 root 5, minus 15 plus 2 root 5 is a number here. Minus 15 plus 2 root 5 is a number here. So a has to be greater than this, but less than this. That means a must belong to this interval. A therefore eventually belongs to minus 15 plus 2 root 5 to minus 1 minus root 5. This is the interval to which a must belong. Yes or no? So again, not a difficult problem, but surely, it will teach you a lot of things. It will get your fundamentals back in place. Thank you so much. Bye-bye.